All right. Going to need a couple, need some help here for this one. Okay. First one, angle of elevation. Guys, we are still talking about sine, cosine, tangent, still talking about right triangles. All right, you got two new concepts, elevation and then the second one, depression. So I am going to need a little help from 3 people here. Okay, all you got to do is literally stand and hold a piece of string. That's what you got to do when you help me out. I'm not going to ask you to do a dance or answer any trivia questions here. Okay, I'm going to start with angle of elevation here. Anybody want to come up and just hold this piece of string for me? That's all I'm asking. Emma, come on up. Thomas, you want to hold the other end for me? Come on up. So you go. You keep going back. There we go. You hold that end. Okay. Emma's going to be my building, my person, my tree, whatever it happens to be. All right. Her angle of elevation. The angle of elevation is always formed from a horizontal line. Pull that sucker tight. Horizontal line and I'm going to ask you to hold that. All right. Put that up near your eyesight for me. And can I get another person to hold this end here somewhere? Put them together for me, Emma. Put them together. There you go. Right in the same hand. Yes, no. Going. Just got to hold it right here for me. Let's go. Thank you, Hendrik. Appreciate it. That was painful. Okay. So right now, first of all, do you see a right triangle in this diagram? If I drew in this side coming down here, everyone see the right triangle? No big deal. All right. Where's the angle of elevation? Well, it's always from this horizontal line to wherever Emma is looking at. All right. She looks up a little more. Go ahead and raise it, Hendrik. Everyone see this angle right here is going to increase. She looks down. That's going to decrease. This angle right here is the angle of elevation. All right. Inside the triangle formed by the horizontal line and the person's line of sight. All right. Again, she looks up towards a building or monument, whatever. That angle increases. All right. She looks down. It decreases. Everyone see where the angle of elevation is always going to be in a right triangle. We all good there? All right. That's all I needed. Thanks, guys. That was tough. Okay. So look at my first example here with Scotty. His eye level, 1.5 meters above the ground. Can you put 1.5 meters somewhere? His eye level. So ground to his eye. Ground to his eye, 1.5 meters. So hopefully some of you, eye to the ground, 1.5 meters. And he's standing 30 meters from the tree. Can you put 30 meters somewhere on your diagram? He's 30 meters from the tree. So hopefully you put it between him and the tree. The angle of elevation of the bird at the top of the tree is 36 degrees. Now remember what elevation was. Eye level up. Remember I had it at Emma's eye level. So from his eye level, there's a horizontal line formed to the top of the bird. That angle looked exactly like when we had those 3 in the middle of the room. That angle, 36 degrees. Everyone all right? Angle of elevation, putting it there. Horizontal, looking up, line of sight, 36 degrees. And it's asking for how far above the ground, who is the bird? So I'm going ground to the bird. How far is that distance? Hey, you guys see a right triangle in that diagram? Finish it, draw it in, please. Finish it. This distance right here. Okay, oh, I should put that in yet. How am I going to find the distance from the ground? How can I find that distance going from the ground to the bird? Can you find one of the sides here on the right triangle? That'll help us get there. What do you got, Bella? Speak up. Go ahead. Well, hold on. I'm not even there yet. Just describe how I'm going to get to this distance here. Find what first? Yep, this side we just drew in to finish the right triangle. I'll call it Y because I already called that X. That's not going to find the distance, but when I add it to what at the end, it will? 1.5. So that's our goal right now. Find the length of this leg using sine, cosine, or tangent, add it to 1.5, and I'll have the full distance. Good? Slight problem, though. I don't have a side length here. I don't have a side. To use sine, cosine, tangent, you guys need a side length. And I don't have a side here. I got 36 degrees and a right angle, but I don't have a side length. Anything else in the diagram gets you a side length. Let's go 26. Nope. Yeah, we have a 26, don't we? Yeah, here we go. What are you, cold? What do we have in the class in an igloo? Let's go. Where's another side you can get me, Jack? Based on everything I've labeled so far, what is a side, a definite side you're confident in this right triangle? $30, right? If he's 30 feet away, that's got to be 30. There you go. It got me a side. Here we go, 22. If I'm going from 36, is this 30 meters? Is that opposite, adjacent, or hypotenuse? Adjacent. And what about the side I'm trying to find? Opposite. I know it's been about 10 days of break, but 28. Nope. 2. If you have the opposite and adjacent side, you can use tangent, just like you did for the Regents problem. Tangent of. Somebody want to finish that equation? Here you go, 7. Yep, good job finishing that equation. 11, want to finish that? Tangent of, what's my angle? We don't have an 11? Sorry, Fiona. You're in the zone. Tangent of? 36. Yep, equals, which one do I put over which? Y over 30. Got it. And just like we did before break, put it over 1, cross multiply. Hey, is this going to be your final answer? No, I'm going to try to drive this home this week. It's not your final answer, so you're not doing what with that decimal you're looking for in your calculator. You're not rounding it yet. Write it all out. $30. Oh, there we go. Make sure we all match up. That's this distance right here. What do I have to add to it to find the total distance? 1.5, like Bella told us at the beginning. So now you can round to the rounding directions in the problem. And when you're ready, 9, 20. Yep. We got meters. Perfect. Questions? Angle of elevation. Horizontal looking up. Well, instead of being on the ground, you could be on top of something. Top of a tree, top of a building, looking down. When I'm looking down, I refer to that as the angle of depression. Do not fall in this trap, though. A lot of you think, hey, this was elevation down here. This one's got to be depression up here. And the answer is no, it's not. It's not the other angle. All right, it's not the other angle in a triangle. Here's how depression is formed. Still with a horizontal line. Okay, so right away this says the angle of depression is 40 from this guy looking down on the building to his friend. Draw that in. It's the angle formed from the horizontal line and you looking down. So take a look, everyone. The 40, that depression, outside the triangle. Okay? It is formed with the horizontal line looking down, that angle. Okay, so it's actually outside the triangle. Everyone all right with depression where that is located? Outside the triangle from horizontal line looking down. All right, we got a couple other values to put on here. The rooftop, 16 meters from the ground. Got it. His eyesight, 1.8 meters from the ground. So 1.8. What's the distance between John and the building? John's friend in the building. So put an X here somewhere. Put an X where you think we're going to find, which side of the triangle we're going to find his friend from the building. All right, we got a right triangle, right? There's a problem, though. Why can't I use that 40? Where is it? It's outside. I need an angle inside to use sine, cosine, tangent. There's two different ways. How do I get the 40 to help me inside? Two different ways here. How do I use that 40 to get one of those two angles inside the triangle? You got it. Bella, one way. Think you got one way? Oh, yeah. Using a little review here. These are both horizontal, so they're parallel. So if that's 40, what type of angles were these? That gives me the right to call that 40. Alternate interior angles. Yes, go ahead. The other way, I could say the alternate interior angles are equal. The other way is, yes, these two angles, the depression and the one next to it, form a 90-degree angle. So they're complementary. So that one's 50. Can we make a class decision, though? You can do it your own way whenever you want, but just so our numbers stay the same. Do we want the alternate interior or do we want the 50? Okay, you got it. Alternate interior, 40. Here we go, 5. What's the x acting as if I go from that 40-degree angle? Opposite, adjacent, or hypotenuse. What is it? Adjacent. And what about all this mumbo-jumbo over here? That's opposite. Okay. With those two sides, sine, cosine, or tangent, which one? 29, which one can I use there? Tangent, yep. Tangent of 40. What are you guys going to plug in there for your opposite? Not 16, because you got a little more than that. It's going from his eye. 17.8. You don't know where that's coming from. I'm adding the 16, height of the building, plus his eye level, 1.8 over x. Yep. Put it over 1, cross multiply. I'll give you guys a minute or two here to get that down, round it to the nearest tenth again. When you're ready, nearest tenth. 25, nearest tenth when you're ready. 20. Yep. Okay. Nice job. I am going to give you the next 2 minutes in your group or by yourself, whatever you prefer. Another angle of depression problem. Okay, another angle of depression problem. Talk it over, make sure you got the diagram correct. I'll give you 3 minutes. Angle of depression of 20 outside the triangle. So draw your horizontal line across. Forms an angle of 20 degrees to the ship. Make sure the 20 is outside, not inside. 20 degrees. 70 opposite. It's because when you cross multiply, you get tangent of 20 times x equals 73. So you want to divide both sides by the tan. You have it backwards. Because you're going to have tangent of 20x equals 73, right? So you want to divide both sides by the tangent of 20. Looks good. Horizontal distance. What's horizontal? Correct. Okay. If I leave out the word horizontal, yes, fine, that would be the distance I want. But since it says horizontal distance, I want this one going across. Okay. Looking good. Why not? Tangent of 20 times x equals 73, and then what do you got to divide both sides by? Well, you got to write it out here, Paul, to help you out here. Tangent of 20 times x equals 73 on the other side. So how do you get that x by itself? What do you got to do with the tangent of 20? Yep, and then put that in a fraction template. Okay, a lot of people doing well, coming around, taking a look. You may have not used 20, you may have used 70. That's fine. Then it would be flipped. All right, but either way, whether you use 20 degrees or 70 degrees in your ratio, should have been 200.6. Going? Any issues? All right. There will come a time where you're going to have to provide your own diagram. All right, so let's slowly go over number 4 here with the airplane, because this is the classic draw your own diagram question. Angle of elevation. So I'm looking down or looking up? Looking ground up now. Horizontal line, looking up. From an airplane, from a control tower, is 7 degrees. All right, now, look, if you want to make me this nice artistic diagram, go right ahead. If you just want to draw a darn right triangle too, I'm okay with that. All right, especially you guys that have probably my artistic ability, control tower, I am put there. I have no idea. Okay, but it's looking out at a plane. That's why I prefer just to do a right triangle. 7 degrees, angle of elevation, looking up, right? So I got the horizontal line looking up. And again, you could do this from here, from the top. You can put this anywhere. 7 degrees. Okay, 7 degrees. We okay on the 7 going there? You got your right triangle. Tower, 200 feet high. So this whole tower, 200 feet high. Here's the part I want to make sure I make clear to you. Altitude, 5,200 feet. Altitude is if the plane is directly above you on the ground. Okay, so this distance right here from the ground all the way to the plane is 5,200. That's what it means by the word altitude. if the plane is directly above your head. It's 5,200 feet above you. Last thing. Notice in the last problem you guys did for me, it says find what is the horizontal distance. Do you see that word here at all? Am I asking for the horizontal distance here? No, all I'm asking is how far away from the control tower from the airplane. If I wanted the horizontal distance, I'd plop that darn word in there. So now what am I looking for if I want the distance from the control tower to right to the airplane? I want this length right here. If I want the horizontal distance like last problem, I'll put the word in there for you. All right, but if I'm just looking for the distance, boom, control tower to airplane. Find that distance for me. All right, so I need to find that side. I got 7. Can you find another side of this triangle? Help me find another side of this triangle because I can't do sine, cosine, tangent without it. Another side of this triangle, 2. 5,200 minus the tower height, so that'll give me this side length must be 5,000, and I'll let you guys go from there. Okay, I'll let you guys go from there. Find the distance from the plane to the tower. $15, what do you end up using here? Sine, cosine, or tangent? Sine, yes. Because you have the opposite and the hypotenuse. So everyone, we should be using sine of 7 is equal to 5,000 over x. I changed the rounding directions on you. It's nearest foot now, not tenth anymore, nearest foot. Pay attention to that. 20 when you're ready. Nearest foot. How far apart are they? 3,000? You're doing sine of 7, right? Equals 5,000 over x. Good so far. You're doing sine of 7 times x. So you did 5,000 divided by sine of 7. There you go. We all good there, Claudia? Okay. Everyone else all right if you have to draw altitude directly above you? All good. Because no more fancy stories now. Last one I'm going to do, a little quadrilateral action, your rhombus. Go ahead and get a 4-sided figure going, A, B, C, D. How do you label it? Whoa, how are you labeling this? Clockwise or counterclockwise? Do not jump diagonally. Make sure you go around here. Don't jump diagonally. Diagonal AC. That is 80 units. BAC is 42. How about the length of diagonal BD? Are they equal in a rhombus? Diagonals equal? Anybody remember? No, so this is not going to be an easy, oh, it's 82. All right. Tell me something about a rhombus that might help me out here. What are those diagonals doing to each other? Bisecting. So we cut that 80 up into 40 and 40. Yep. Let's cut that 80 up into 40 and 40 for us. Know anything else about rhombus? Diagonals. Perpendicular. Perfect, because now you have a right triangle. How can I get to diagonal BD? You're not going to get there right away. Give me a plan. Let's make a little plan here. Anthony. Hey, let's find this part right here and double it at the end. Let's find that part and double it. All right. How do I find that part then? 3. Here we go. 42. What's the x? Opposite, adjacent, hypotenuse. That is opposite. And how about the 40 I labeled? Adjacent. So which one of the 3 can I use? Tangent. Perfect. Tangent of 42 equals opposite over adjacent. And notice what I'm not doing to this one. 36.0161617. And then what do you have to do to find the diagonal? Take that part, and because it's getting bisected, multiply it by 2. And I said nearest integer, so whole number. 4, nearest whole number here. 72 for the diagonal. We're good there. And I'm going to let you by yourself or with your group finish up and do part B now. Find a side. A couple different ways you could do it. Find a side now of the rhombus. Couple different ways, and sine, cosine, tangent might not be one of the ways you want to use, which is fine. The only thing you can't use is tangent. If you do use sine, cosine, or tangent, and you're going to use part A's answer, make sure you use the one before you multiplied by 2. Don't use 72 in there. That's the whole diagonal. And no matter which method you used, when you're ready for me, whether you use Pythag, maybe use sine, maybe use cosine, any of those 3 would have worked. 14 when you ended up with one side, nearest whole number. Not here. One job. 5. $54. Yep. Whether it be Pythag or sine or cosine. Questions? Okay, I'll let you guys go. You got some time to get a couple done. Yep, 1 second, if you